Hi Year 12s, welcome to the second last video from me. In this video we'll finish off chapter 6 by considering a couple of exam questions where we get to apply circular functions to a real-world context. I should note at this stage, because we haven't done calculus or probability, there are limited things that we can do with circular functions. Once you learn differentiation, integration, and probability density functions, the number of possible applications with circular functions will grow tremendously. So consider this the beginning rather than the end of your experience with circular functions. So let's get underway. I've just got 2 exam questions for you, and I will demonstrate how to use the CAS as well. So in this first question, the context is you've been given a clock and we want to track the movement of the minute hand over time. We're given some crucial information. We are told that the minute hand is 10 centimeters long, and we're told that the clock face itself has a radius of 15 centimeters. So that's this distance here from the beginning, from the bottom to the middle, and 10 centimeters is here. Okay, so what we are told is at 12 noon, hopefully you know what this looks like on an analog clock. Both hands will be pointing upwards. And what we want is for t minutes after 12 noon, define a function h of t, which tells me the height of the minute hand after t minutes have passed. So let's think logically for a moment. The period of my graph is going to be 60 minutes because the minute hand will make one full revolution around the clock every 60 minutes. Secondly, at time 0, the height of the minute hand will be 15 plus 10, which gives me 25. Once I know these two things, the choice is pretty straightforward because I can immediately rule out a few options. For example, it can't be anything involving 15 plus a sine graph because sine of 0 is 0. So this rules out options A, B, and C, which narrows it down to D and E. So let's think for a moment. Both of these graphs have 15 plus a cosine graph. And that should make sense because I'm expecting the minute hand to start at its maximum position, 25, and go down to its minimum position, 5. So it makes sense to be adding a cosine graph. What differentiates options D and E is whether the denominator is 60 or 30. So here we're going to use the period. Suppose that h of t is 15 plus 10 times cosine of nt, where n is the coefficient of t. Then using my knowledge of sine and cosine, the period is 2 pi on n, which equals 60. Multiplying both sides by n, I get 2 pi equals 60n, and dividing both sides by 60, I get n equals 2 pi on 60, which simplifies 2 pi on 30, and therefore option E is correct. So, not a difficult question. What's difficult is reading the question and solving it in a minute 30 seconds. That's what's tough. Okay, on to the second example. All right, so here we're given a trigonometric function. Capital T tells me the temperature at time lowercase t, where lowercase t is in hours. We're also given some useful information. We're considering a 24-hour time period, I should say. So lowercase t ranges from 0 to 24. Given this equation, we can immediately answer parts A and B. So part A asks for the maximum temperature. Now, when you see the word maximum, once you've done some calculus, you'll immediately think, oh, set the derivative to 0 and solve and find that value of t, substitute it back in. But we actually don't need to do that, because here we should remember that cosine is bounded between -1 and 1. So therefore, if I multiply it by 2, it's now bounded between -2 and 2. And if I add 25 to both sides, well, to everything, I get to 2 and 25, 2 plus 25, and -2 plus 25. And so h of t is between 27 and 23. 25 plus 2 and 25 minus 2. So the maximum value is 27. And this is what I would just write 25 plus 2, which equals 27. This is the reasoning that's happening in the background. Okay, part B. Here we are told to find the period. So suppose that my coefficient of lowercase t is pi on 8. Then the period is going to be 2 pi divided by pi on 8. And that's 2 pi times 8 on pi, which is 16. And since this is exam 2, it's good to provide your answers with units. So I will say it's 27 degrees and 16 hours. Okay, let's continue. We're almost done. So now we'll do part C and D. Okay, part C, find the smallest value of t for which capital T is 26. So essentially, I want to solve this equation. 25 plus 2 cosine of pi t on 8 equals 26. Now, this is exam 2, so I'd be tempted to just shove this into the CAS calculator and get it to give me an answer. But what I'm noticing is that this question is actually worth 2 marks. So the instructions in exam 2 are to show working if a question has more than 1 mark. So I think here we should show some working. We shouldn't just write down the answer. So what might they be looking for? Well, I think we'll start by saying that 2 cosine of pi t on 8 is 21. Subtracting 25 from both sides. Cosine of pi t on 8 is a half. And since we know that the inverse cosine of a half is pi on 3, that tells us that pi on 8 times t equals pi on 3. And so t equals 8 on 3 hours. I think, personally, without knowing all the details of how this exam was marked, that you'll get 1 mark for the answer, and you'll probably have 1 mark for writing down probably some combination of these 2 equations here. Okay, so because from here to here, you've clearly shown your recognition of the angle pi on 3. Now, suppose that we've done this, and now we want to check our work. So now we can get the CAS calculator out. So I've got it here. And we can use the solve function. So what we want to do is type in 25 plus 2 times the cosine of pi times, I'll use t divided by 8. And I want to solve this to equal 26. So I'll just make that a bit bigger so you can see it. So what I'm going to do is I'm going to solve this on the interval 0 is less than or equal to t is less than or equal to 24, because that will set up part B as well. Actually, let's do both. So what I'll do is I'll solve this for t, And those are the three values. But I can get rid of the domain as well. So if I do just this, you'll notice that we get a general solution. So this would be 16n minus 8 on 3 and 16n plus 8 on 3, where n is an integer. That's what the const n is saying. And the reason why they are numbered 1 and 2 is to sort of differentiate between the families of solutions. So I've got one family with minus 8 on 3 and another family with plus 8 on 3. Okay, so based on this work, we know that our answer to part C is correct. And now part D is asking how many hours during the first 24 hours have temperatures larger than 26. So now if we do this, if we solve this on the CAS calculator, I'll say solving using the CAS for t between 0 and 24 gives t equals 8 on 3, 40 on 3, and 56 on 3. Now, this question has an inequality. It actually wants greater than or equal to. Now, without a graph to visualize this, it's nearly impossible to tell what's happening here. You could draw the graph by hand. I personally think it's easier in exam 2 to just sketch the graph on a calculator. So we'll go ahead and do that. So I'll copy this over. To sketch a graph, what we want to do is click on this parabola icon here, click inside, click on the Y1, Y2 button, and enter your graph that you want to sketch. Click on the button with the 4 arrows pointing outwards. Our domain is 0 to 24. And our range is 23 to 27. Okay, and then press the parabola icon again after ticking the box to sketch the graph. And this needs x, not t. Okay, now we want values that are 26. So here we can go to analysis, gsolve, x calculation, and enter, x calculation with a y value of 26. And you can see 2.6667 tells me that this is 8 on 3 here. And so for values between 0 and 8 on 3, it's above 26. And then if I go to the right by pressing the right arrow, the next one is 13.3333, which is 40 on 3. And this one, 18.667, this is the last solution. What is that? 183654 plus 256. Okay, so based on our work, the time that t is greater than or equal to 26 is 8 on 3 minus 0. That's this first region here. So 0 to 8 on 3. Plus, in between 40 on 3, which is here, and 56 on 3, which is here. So that's 8 on 3 plus 16 on 3, which is 24 on 3, which is 8 hours. Okay. Now, notice how much easier this became when I had the graph available. If I go back to the to main, suppose I try to solve this with an inequality instead of an equal sign. and I keep the domain in there, if I press enter, you'll see that the calculator wasn't able to give me a set of solutions. So unfortunately on the class pad, you don't get nice domains when you submit an inequality like this, compared with something like, say, this here. Oh, that's interesting. That one also didn't work. X squared minus x equals 0. Oh. That was unexpected. Just 1 second. Yeah, and now I'll make this greater than or equal to. Yeah, so that worked. That's really interesting. So when I factorized it, it didn't work. That's fascinating. Okay, you learn something new every day. That's devastating. To think that you'd have to expand your brackets to get your solution. Okay, one final remark I want to make before I wrap this video up is you'll see down here it says RAD, that's radians. Please make sure that you're clear on which degree mode you are working with before doing a trig question, because if you use the wrong mode, you'll get the wrong answer and you'll lose basically all of the marks. My advice is you use your scientific calculator for degree calculations. For instance, if you're using that for physics, just leave it in degrees mode all the time. And for methods, do your radians calculations on the CAS calculator. All right, so that wraps it up for the Chapter 6 videos. There is one video left where I'll go through the test that I gave in week 10. And that's it from me. So look forward to seeing you in the final video. Thanks.